All right, this problem, I would say, is a level 3 problem out of 3. This is a hard problem because you have to do so many steps. So let's just break it down. You've got this whole problem, and it wants to know what's a possible value of m. And you might think, well, there must be an infinite number of values, and there's not. And so one thing that kind of alerts me to maybe a possible answer is there's probably going to be a whole number. It's probably not going to be too big. It's probably not going to be too far negative. I don't know. I just kind of get into the heads of an SAT test or a middle school test, eighth grade, ninth grade, 10th grade. So let's just kind of go through this. First thing we can do is we can break this problem up into two problems. That's one problem. And it's legal to do this. And this will make it a whole lot easier to kind of solve. I'm going to solve this problem. And then I'm going to go through and I'm going to solve this problem. But let's first do this one. Now, whenever I see a fraction, I automatically want to get rid of it. I'm going to multiply everything through by 5. This will get rid of a fraction. 5 times negative 8 is negative 40. Less than negative 3m, because the 5 and the 5 cancel. 5 times 1 is 5. Don't forget that. Now I just solve it. And here I have negative 45 less than negative 3m. And I'm going to divide by negative 3. Now, when I do this, I need to keep in mind I've got to flip this inequality because I'm dividing by a negative number. So I get 15 greater than m because I flipped inequality, and 45 divided by 3 is 15. The negatives cancel. So that's one solution to the left side there. Now the right side. I'm going to just split my paper up here. Negative 3/5 m plus 1 less than or equal to negative 16 over 5. All right, once again, I'm going to multiply everything through by 5, so I get rid of that fraction. 5's cancel here, so I'm left with negative 3m plus 5 times 1 is 5. The 5's cancel here, so it's less than or equal to negative 16. Now I'm going to solve negative 5, negative 5, negative 3m less than or equal to negative 21. I'm going to divide by negative 3. And remember, when I divided, I got to flip this inequality. So it's now going to be m is greater than or equal to 7 because the negatives cancel. So I have these two inequalities. You could kind of think about it like this. M has got to be 7 or bigger, and m is less than 15 because 15 is bigger than m. So let's kind of go through it. Could 7 work? Yeah. 7 is the same as m. It's the equal, and it's less than 15. 15 is bigger than that. Does 8 work? Yes. Does 9? Yes. Does 10? Yes. 11? Yes. 12? Yes. 13? Yes. 14? Yes. 15? No, because it's not equal to it. So it's got to be, m has got to be less than 15. Now, another way to kind of look at it, and this might kind of run out of room here, but I'm going to do it right under here. One way that you'll see math people write this is they'll write both of these into one inequality, or one kind of equational inequality, I call it. And it's going to look like this. 15 greater than m, and m is greater than or equal to 7. Or I could flip this around. This might be a little easier to kind of look at it. It's 7 less than or equal to m less than 15. So that's really kind of what you'll see as a final. And then if you check all of these, they all work. And these are the only numbers that work. I guess you could have an infinite number of numbers with decimals. But for this type of problem, they're going to want whole numbers.